Hey guys, this is Tori from Hat's Tutors, and this is part 2 of the series, The Basics of Organic Chemistry. Today we're going to be learning how to name alkanes. So if you guys recall, during the last video we talked about the properties of alkanes and naming straight alkanes. So if you guys remember, straight alkanes such as methane look something like this, and they are just one chain, and the naming of them correspond with the amount of carbons within the chain. But today we're going to be looking at alkanes with subbranches. So rarely do alkanes only have one branch, and oftentimes they have subbranches. So as you can see here, there are many different branches of alkanes. So how do we name this? Let's go over the rules. So rule 1 of naming alkanes with subbranches is to identify the longest continuous chain of alkanes. So what is the longest chain here? Evidently, people might think it's this, as this appears to be the longest chain. But actually, the longest chain in this case is a chain that spans over here and goes down and follows it here. Because as you can see here, this part of the chain only extends with 2 more carbons, whereas this part of the chain extends with 3 more carbons. Now let's move on to rule number 2. Rule number 2 states, number the carbons such that the substituents are at the smallest carbon by number. So let's take a look and identify the substituents first. We have said this is the main chain. So these side branches or side chains are the substituents. So what is meant by numbering the substituents such that they are by the smallest carbon by number? So what is meant by this is that they are connected, the carbon they are connected to that is a part of the main chain has to be minimized by carbon number. And we can either name the carbon from this direction or from the other direction, so this direction. As we can see here, we chose this direction to minimize the carbon number that is connected to the side chains. As you can see, if we name from this other direction, as shown here, it would be 1, 2, 3, 4, 5. And we would have the carbon number being 5 instead of 4 here. But since we want to minimize it, 4 is better than 5 in this case. So that is why we number it from this direction in this case. So rule number 3, identify the branch substituents to name them. Change the usual ending of ane to il. So as we have previously established, this is the main chain, and these two are the substituents or the branches. So as you can recall, this would be called a methane. And this would be called an ethane usually. But since we want to change the ending from ane to il, this would become methyl, and this would become ethyl. So putting it all together, rule number 4. So the first part of putting it all together is we want to write the number of the carbon that the substituent is connected to before the substituent, separating the two with a hyphen. So let's go back here. So as you can see, there's methyl and there's ethyl as 2 substituents, and they're connected to carbon number 4. So to write them, we would have to put 4-methyl, separated by hyphen here, and 4-ethyl. So then rule number 2, if there are multiple different substituents, list them alphabetically and put hyphens between them. So in this case, there are multiple substituents, and we see ethyl E is before the M alphabetically. So in this case, we would put 4-ethyl and 4-methyl. And we would finish this name off with the name of the main chain. In this case, since it's not a substituent, we don't change the name from ane to il, we just keep it as ane. So as you can see, the main chain is 8 carbons long, and that would be an octane. Thus, the combined name of this organic molecule would be 4-ethyl, 4-methyl, octane. And let's just go over the last rule really quickly. It says, if there are multiple of the same substituents, put the corresponding carbon number of each one together, separated by commas, and add a prefix, di, tri, etc. to symbolize the number of similar substituents. So it is important to note here that this di and tri, tetra, etc. does not contribute to the alphabetical ordering of the substituents. So that means that if we have two methyls, so dimethyl versus like one ethyl, the ethyl would still go before the dimethyl because E is still better than M, and this di part is not included in the alphabetical ordering. And if this doesn't make sense to you yet, we will have examples later on to demonstrate this. Let's name the following. So as we can see here, this is one of the organic compounds or molecules. And we can choose either one of these two chains. So let's see which one's longer. We have this chain or this chain. Now they appear to be the same length, both being 6 carbons long. So which one do we choose? Well, honestly, either is fine in this case. So let's just go with the horizontal one, since it's more easy to identify. So how do we number this then? Well, we want a number such that this chain, this branch, the substituent, is at the lowest carbon by number. So this carbon has to be the lowest number. So if we number it from this direction, it would be carbon number 5. But if we number it from this direction, so from here, this direction, it would be carbon number 2. So we would honestly prefer carbon number 2. So let's number it from this direction then. And now let's name this thing. Well, we can see that this side branch over here, it's a methyl group. And it's connected to carbon number 2. So it would be 2-methyl hexane. Got it? And now let's move on to the more complex one. This one. Wow, this one looks really complex. But don't worry, it's not too bad. First, let's find the longest chain. So this chain seems obvious. 4 carbons long. But if we can see here, we can actually make a 5 carbon long chain. So let's go with the 5 carbon long chain then. So to minimize the number of the substituents connected, let's see. If we number from this way, so from left to right, it would be 1, 2, 3, 4, 5. If we number it from right to left, it would be 1, 2, 3, 4, 5. So as you can see, we have a branch over here, a branch over here, and a branch over here. If we number it from left to right, the branches would be at carbon 3 and carbon 4. But if we number it from right to left, the branches would be at carbon number 2 and number 3. So we want to number it from right to left again. And in this case, since we have 3 methyl groups, one methyl group here, another here, and another here, we would have to employ the tri prefix. So let's get started. So we first write down trimethyl, pentane, with 5 carbons being in the main chain. But how do we number this before? Well, if we remember correctly, we have to put all the numbers of the 3 methyls before, separated by commas. So 2 of the methyls are connected to carbon number 2, and one of them is connected to carbon number 3. So it would be 2, 2, 3, trimethyl pentane. So, as you can see before, I've drawn a lot of these random structures. But now we're going to learn how to actually draw all these alkanes. So the first structure that you probably need to know is called the complete structure. And this is pretty similar to like the Lewis structures you guys might have been doing. As you can see here, everything is shown. Similar to a Lewis structure. And then we have the condensed structure. If we see here, this is written with the condensed structure. And this simplifies the presentation of the structure. As we can see here, we can, instead of showing this CH2 as something like this, as shown in the complex structure or the complete structure, it is instead shown combined together as just the CH2. And chemists usually prefer cleaner structures. And although this one's quite nice, there's an even cleaner one. And this is a line diagram. And this is probably the most common structure you will see for organic chemistry. So basically a line diagram, it shows carbons as the vertices or the points along this line. So all of these are carbons. The hydrogens are simply omitted, because it is assumed that you will know how many hydrogens are connected. And you can tell because a carbon needs 4 bonds, right? So if it has 1 bond with another carbon, that means it has 3 bonds with the hydrogen. And don't worry, we'll get some practice with this. So let's go. Draw the following: 3-ethyl, 3,4-dimethylhexane. And we're only going to be focusing on the line structure today, but of course you could also draw the other 2 structures. But I want to emphasize because the line structure is the most important one. So when you see one of these complex molecules, how do you approach it? Well, for me, I like to approach it from the base. So we know the base is hexane. So let's draw hexane first. 1, 2 carbons, another line, 3 carbons, another line, 4 carbons, 5, 6. So this will be a hexane. And now let's add the 3-ethyl and the 3,4 dimethyl, sorry. So then we have 3-ethyl here and 3,4-dimethyl here. So you can see here, this is the ethyl, two carbons long. So as you can see here, we've added the ethyl, which is this group, and the 2 methyls, which are these 2 groups. And this is 3-ethyl, 3,4-dimethylhexane. So I just want to thank you guys for watching the video, and I hope you guys stay safe. Thank you.